call is now being recorded.
So here you are going to plot a sine wave. Are you able to hear?
Yes, miss.
Yes, okay. So now we are going to plot a sine wave. So you define the frequency of sinusoidal signal as 50. Okay, so this frequency as 50 and time is equal to 0 colon 0.002 colon 0.1. That is an array. Okay, so you define this t and y equal to sine of 2 pi ft. Okay, so you have defined f and you have defined t. So y equal to sine of 2 pi ft. So that is our sinusoidal signal. Y is equal to sine 2 pi ft. Now you plot. How can you plot? The x-axis will be your t. The array you have created now, the t will be your x-axis and the y-axis will be your sinusoidal signal. So plot have two arguments. One is x-axis argument and the second one is y-axis argument. Okay, the first one is t. That will be your x-axis. X-axis ranges from 0 to 0.1. So what is the meaning of 0 to 0.1? 0 is the initial value of the array. 0.1 is the final value of the array, which is having an increment of 0.0002. Okay, so 0 to 0.1. That is an array you have created, and your x-axis will be 0 to 0.1. And what will be your y-axis? Your y-axis will be sinusoidal. Okay, that means sine of 2 pi ft. Okay, so you will be getting a signal with frequency 50 hertz. Okay, now after that, you can take this grid on and hold on. I hope you know the functionality of grid on. Signal of 100 hertz. So how can you plot? F equal to 100 hertz. Again, the same t you are defining the same t. Now y equal to sine of 2 pi ft. Okay, y equal to sine of 2 pi ft. Okay, now f is defined as 100 hertz. Now you define plot of t comma y. X-axis will be your t array and y-axis will be your sinusoidal signal. Okay, now hold off. So when we run this, you will get two sinusoidal signals. So are you able to see the figure window? If you are able to see the figure window, you can see two sinusoidal signals here. One is in red color and other one is in blue color. You can see these two sinusoidal signals here. And one is having, the blue color is having a low frequency and the orange color or the red color is having a high frequency. That means the blue color signal is of 50 hertz and the red color signal is of 100 hertz. So two different frequency signals you can see here in the graph. So two sinusoidal signals you can see. One is the blue color signal and the other one is red color signal. Okay, in the red color, it has got higher frequency. Okay, higher frequency which is 100 hertz. And the blue color is having a low frequency which is 50 hertz. I hope this is clear. And if you want to plot these in two separate figure windows, suppose you want to plot these two different plots in separate figure window. You just type before the plot, you just type figure. Okay, just before the plot function, you type figure. Semicolon. Then the other plot. Okay, you type figure. Okay, so before the two plot functions, you type figure semicolon. Here also you type figure, then plot. Okay, now you run it. Save and run this. You will be getting two figure windows. You can see the two figure windows parallelly. So here this is one figure window. This is figure 1, which is a sinusoidal signal. So this is figure 1, which is a sinusoidal signal or sine signal having 50 hertz frequency. Okay, this is a sinusoidal signal having 50 hertz. What is the time period? This one particular cycle. This is one cycle starting from here, this 0 to this one. Okay, this point. Okay, that is point note 2. This is one particular cycle. Again, this is another cycle. This is another cycle. So this is the time period. This whole interval is the time period, isn't it? Time period of a sinusoidal signal. This whole interval is the time period of a sinusoidal signal. Okay, and 1 by time period will give you the frequency. Okay, so time period, just the inverse of time period will be giving you the frequency. Reciprocal of time period will give you the frequency. So 1 by time period will give you the frequency of signal. So this is the other signal, which is 100 hertz sinusoidal signal. So here every axis is marked as 0 to 0.1. Why it is 0 to 0.1? Because you have defined your x-axis as 0 to 0.1, isn't it? Here in the program, you have defined your x-axis. This is your x-axis. Okay, this is your x-axis. You have defined your x-axis as 0 to 0.1, isn't it? So that is why the figure is displaying like this. The x-axis will be 0 to 0.1. I hope this is clear. So two frequency signals you have plotted. Now let me plot. Okay, I'm just plotting a single sinusoidal signal and I'm not defining any frequency here. I'm just plotting a single sinusoidal signal and I'm not defining any frequency here. Okay, just I'm typing sine of t. That's all. Okay, where t is, you have defined t as 0 to 0.1. So you have defined your t. Okay, just you type sine of t. Okay, you are not defining the x-axis here. Okay, so plot just y, not defining any x. So plot of just y will give you just the y plot. What is y? Sine. Y equal to sine of t will be your answer. Okay, you are not defining Students, can you hear me? Students, എവിടം വരെ കേട്ടു എന്നൊന്ന് പറയാമോ?